Okay, so we're going to do opposite of b over 2a, which in this case will be the opposite of 2 divided by 2 times negative 1, which comes out to be negative 2 over negative 2, which is 1. So that's your h value for the vertex. To get the k value, we have to substitute 1 in for x and simplify. 1 squared is 1 times a negative, 2 times a 1. Negative 1 plus 1 cancel, so y equals 2. So the vertex is going to be 1, 2. That means the axis of symmetry is going to be the equation of the line x equals 1. It's opening down, so that means it's going to have a max value of 2. And the range is going to be the set of all y's such that y is less than or equal to 2 because it opens down. Number 2, same thing. So the opposite of b over 2a is 4 over 6, which is 2/3. So the x-coordinate is 2/3. Let's plug in 2/3 and see what we get out of it. Okay. Square 2/3, which is 4/9. 4 times 2/3 is 8/3 minus 2. So y equals, the 3 and the 9 cancel, so you'll have a 3 down here. So 4/3 minus 8/3 minus, might as well put this in thirds, so 6/3. 4/3 minus 8/3 is negative 4/3. Negative 4/3 minus 6/3 is negative 10/3. So that means the axis of symmetry is the equation of the line x equals 2/3. It is opening up, so it has a min value of negative 10/3. And the range, it's opening up, so it's going to be the set of all y's such that y is greater than or equal to negative 10/3. Number 3, again the same kind of problem. So the opposite of b over 2a. So that's 1 over negative 2, which is negative 1/2. So let's plug that in, see what we get for an output. Minus negative 1/2. So we square this to get 1/4 times a negative. Negative times a negative is a positive. So it's negative 1/4 plus, put this in fourths. So this will give us 1/4 as an output. So that's my k value. That means that the axis of symmetry is x equals negative 1/2. It's opening down, so it has a max value of 1/4. And the range is the set of all y's such that y is less than or equal to 1/4. Number 4, graph the function. So we want to find out what the vertex is here first. So the opposite of b over 2a. So this is going to be negative 6 over the 2 and the 4 can cancel, so it's negative 3/2. So when you do this, it's going to be negative 6 over 1 times the reciprocal of the denominator, so negative 2/3. The 3 and the 6 cancel, so we're left with negative 2 times negative 2, which is 4. So that's going to be your x-coordinate of the vertex. So now what we have to do is we have to input positive 4 in for x to see what our output is. So let's do that. 4 squared is 16. 6 times 4 is 24. This 4 and 16 can cancel. So you get negative 12 plus 24 plus 6. So that comes out to be 18. So 4 comma 18, it's beyond the graph, so it's probably like way up here somewhere. There's your vertex. We do know that the y-axis intercept is 6, so let's do that. And that is 1, 2, 3, 4 units to the left, so we have to go 4 units to the right. So we will have the point 8, 6 as part of the graph. So if you just want to connect these, it's not exactly the greatest looking parabola here. Let me just fix that. It hits at 6, so something close to that would be acceptable at this point. Eventually we're going to find out how to solve for the x-intercepts, and then you can get a more accurate graph. Alright, so write the function in vertex form. So if we need it in vertex form, we have to find the vertex. So the opposite of b over 2a is going to be negative 3 over, the 2 and the 4 can cancel, so 9/2, which is negative 3 over 1 times the reciprocal, because you're dividing fractions. This 3 and 9 cancel, so the x-coordinate of the vertex is going to be negative 2/3. So let's plug that in. 9/4 negative 2/3 squared plus 3 times negative 2/3 minus 1. You'll have 9/4 times, square this, you get 4/9, minus, because it's a positive times a negative, the 3 and 3 cancel, so you have a 2 minus 1. 9/4 times 4/9 all cancel, so you have a 1 here. 1 minus 2 minus 1 is a negative 2. So now we can put this all in vertex form. So y, opposite of this, equals a, which is 9/4, times x, opposite of that, squared, and that's your answer. Alright, number 6. If we remember for this term here, negative 5, equals the opposite of b over 2a. The x value of the vertex always equals the opposite of b over 2a. Now it would be nice if we knew either a or b. We don't know a, but we do know b. b is 10. So let's substitute that in. Multiply both sides by 2a. So you get negative 10a equals negative 10. So a is 1. If a is 1, let's put that in there. So 1x squared, so let's leave it x squared, plus 10x plus c. So let's substitute this point in. So negative 27 equals negative 5 squared plus 10 times negative 5 plus c. Negative 27 equals 25 minus 50 plus c. This is negative 25, and then when we add 25 to negative 27, we get negative 2. So the unknown coefficients were a and c, and we have them here and here. Alright, so for the system, we're going to choose the method that seems easier. I'm not going to choose elimination on this one, because this top one is already solved for y. So I'm just going to take this and substitute it for y. So 3 parentheses, 2/3 x minus 3, close parentheses, equals 18. So negative x plus 3 times 2/3 is 2. So 2x. 3 times negative 3 is negative 9. Negative x plus 2x is x. I'm going to add 9 to both sides. So x is 27. So now that we know that x is 27, we can plug it in. Let's plug it in the top one. 3 goes into 27 9 times. So 18 minus 3 is 15. So your solution is 27, 15. That's the point of intersection. Number 8. So we want a perpendicular line to this. So that means the slope of the perpendicular is going to be the opposite reciprocal. So the opposite sign of this and the reciprocal of that. That's your new slope. That's your point. Use point-slope form. Makes things easy. So y minus 4 equals negative 3/2 x plus 5, since it's the opposite of these. Number 9, write the equation that passes through these 2 points. So we're going to use the slope form. So y2 minus y1 over x2 minus x1. That gives us 5/3. Now that we have the slope being 5/3, we also have points here, so we can put these together. So using the first point, it'll be y minus negative 2, so y plus 2 equals the slope times x minus x1. That's acceptable. Using the second point, y minus y2 equals the slope times x minus x2. Sorry, x minus x1. Either of those is correct. The last one, it says write out an explanation describing how the vertex is related to the max or minimum value of the parabola. This is a pretty easy explanation, because if you look at the vertex h comma k and you compare it to what the maximum or minimum value is, the max or min value is always the y-coordinate of the vertex. So that's all you would need to say. The y-coordinate of the vertex is the value of the maximum or minimum point on the parabola. So that's pretty much it.